So I guess my first question is, what are the most important SQL pattern a data analyst must know?
Yeah, that's a good question. So I recently wrote a book on SQL patterns where I cover four categories of patterns, and what I find to be the most useful, the most important ones are one is composability patterns, what I call composability patterns, which is how do you structure your query so that it's easy to read, easy to understand, easy to debug, and easy to maintain, not only by you in the future, but also by your colleagues or people that will come after you. So that's the first one, composability. Second one are patterns about performance. So performance patterns are basically, the idea is to try to make the search space for the data that you need smaller before you do any sort of searching. And what I mean by that is you need to filter your data before you join it with if you, especially if you have a very large table, millions or billions of rows, you want to restrict the rows to just the ones that you care about. For example, if you only need data for the last month or for the last 90 days, you need to filter that beforehand before you do any joins or before you do any aggregates, as opposed to joining the massive table and then doing filtering after. This is to improve the performance of the, not only to improve the performance of a query, but also because a lot of data warehouses like a lot of cloud data warehouses like BigQuery and Snowflake usually charge by the utilization, so how much data you scan, how much compute you use. The less you use, the cheaper your query is. So you're basically saving both yourself and your company money in the long run. And then the third type of patterns are what I call robustness patterns. So what I mean by that is, so real world data, whether it's coming from a website or from your internal systems, tends to be messy. There's a lot of changes that happen over time. New columns are added, new data types are created. There's potentially missing data. There's potentially duplicate rows. There is incomprehensible formatting. For example, a date that was formatted as year dash month dash date all of a sudden is now formatted as month dash year dash date. And you have to be able to deal with this so that your query doesn't break. And these are what I call robustness patterns. Now, I could go into detail into some of them. And
So I would like to go a little bit in the detail. Can we go back to the composability? From there, I
yeah,
will drill down in these three patterns. I think these are all three are very important. So let's talk about composability. What I understood from you that have a small functions written, and then you can compose your big query using the small pieces of query, so people can understand
yeah,
uh, the big query in terms of breaking it into small queries.
yeah, exactly.
That's what you meant
E-
by
e-
that.
Exactly.
Okay.
So what I've seen in my career as kind of an analyst and a data engineer and analytics engineer, basically I worked in the data field for more than a decade, 15 plus years. I've seen a lot of analysts write code that is very long, for example, 200 lines, 300, 400, 500 lines of code of SQL, and everything is written in one giant statement, making it almost impossible to understand, to
To
debug,
debug, yeah.
to maintain, et cetera, et cetera. And so, what you, with composability patterns, what you do is you use CTEs. CTEs are common table expressions.
Hmm.
They came onto the SQL standard, I believe, around 2008, but not all vendors of databases implemented them right away. So, for
Right.
example, MySQL waited until version 8 to implement them. And so, if
Mhm.
you have like an earlier version of MySQL, for example, you will not be able to use them. Postgres also took their time implementing them. I think they implemented them a little bit later, a little bit earlier than MySQL, but still earlier versions of Postgres did not have CTEs. When I first saw CTEs, it was like a magical button. So all of a sudden, because I was used to writing queries with subqueries, right? Subqueries is the typical way that you
Right.
would write SQL before CTEs, but subqueries you tend to be very nested. So you have a subquery nested with another
Right.
subquery nested with another subquery. You could go down to the levels like 3, 4, 5 levels deep and then you kind of
Right.
work your way backwards, but it's impossible to read and understand if you're using subqueries. With CTEs, you define kind of a small temporary table that contains, say, results from one or two tables that you join with maybe like an aggregate function, maybe a little bit of filtering, and you define, okay, here are the leads from last month, right? So then I take
True.
this, then I join it with another table further down, um, with another CTE perhaps, so you can actually chain multiple CTEs. You can use another
Mm.
CTE within a CTE as long as it's been defined ahead of it. And this way, you can sort of break up your query into manageable, sizable pieces that ultimately
Right.
lead to the same potential result that your large 300-line query led to. But now it's a lot more maintainable
Right.
because someone can go and look at your code and be able to see, okay, they're filtering data here, and then they're joining it here, then they're defining a new column in here, and then finally they get this result. So they can see exactly where like an error occurred. Uh,
What's
what's
happening? Yeah. I will say a big anti-pattern can be if you see any SQL stored procedure more than 100 line, something is
something is
wrong. You are
exactly,
always,
yes. Now you can
yes.
extend this further. So I would notice, for example, in my previous job, where I was basically looking at analysts' code that they were writing, and I
Mhm.
was sort of verifying the code and checking for errors and things like that. I would notice that they would kind of reuse the same chunk of code in multiple places. So they would define, for example, a CTE and then copy and paste that exact same chunk in multiple queries. Now you can use the same CTE within the same query. But the scope of it is kind of limited. It's limited to the query that you're running at that time. So
Mhm.
you cannot use it
Mhm.
in another query. Like for example, in programming languages like Python or JavaScript or C++, et cetera, you can define like a function in a library. It's known as a library. You define it as a function in a library, then you can import it into multiple pieces of code, multiple files that you needed. Thus, it makes your code
True.
a lot more composable, right? So you import this function and then you just use it. So
Right.
your code looks a lot smaller. With
Right.
SQL, this is not as easy, but there is one way to do it. So instead of, like, if you notice that the same CTE you're using in multiple files, it's probably a good idea to take that code and put it into a view. So views are objects in the database that to the user look like a table. So you can do select star from
Right.
view, from the view name. But underneath the view, there's basically a SQL query that gets executed each time that you select from the view. So by
True.
turning your CTE into a view, now the view exists in the database, so it can be used across multiple SQL files, right?
Yeah. That's a very important tip. I think this is one way to simplify your query, having views and CTEs. And I believe in the view, you can index also
Yeah, yeah. If you're getting, so if
the
you
data.
are using databases like Postgres or MySQL, which are relational databases, SQL
Right.
Server, Oracle, etc., using indexes is one way to improve the performance of a query. So you can
True.
use indexes in views, and you can only
Mm.
expose, for example, you can expose columns that you know have indexes, so users can only select those columns or filter by those columns or join by those columns, thus making the
Right.
query more efficient, more performant.
Yeah.
Whereas
True.
in cloud data warehouses, for example, Snowflake or BigQuery, there's no, okay, there's a similar concept in Snowflake to indexes. uh, it's called like micro partitions, but it's not the same as an index. And in BigQuery, you don't get any indexes. Every query does like a full table scan. So in
Right.
those databases, you don't have to think about indexes as much as you do if you're using something like a MySQL or Postgres or SQL Server for your queries. Another object that you can use aside from views are what's known as user-defined functions, or UDFs. They are
Hmm.
the same as views. However, instead of doing select star from the function name, you actually call the function with a parameter, and it returns either a singular value back to you, or it can return like a table, like a full table result. Um,
Right.
it's up to like the analyst or the engineer to figure out whether they need a function or a view. typically functions are used for like parsing stuff. For example, let's say you have a particular JSON
True.
file that's always the same and you need to parse it. That usually doesn't fit into a view, so you would fit it into a function, and then you call the function from your select statement, just like you would call like a standard SQL function, um, like a string parsing or whatever. So you say select function
True.
name, give it the parameter, and then it gives you back the results. So that's another way
Right.
to improve the composability of queries.
True. So if I see all these three, I think with function, there's a performance implication because nothing is cached there and it's
Mm.
running on the live
Mhm.
data. So if these three suggestions you have for me, I think I'll put on top, try to make a view,
Yep.
and otherwise make a CTE. And the third is the function. Is this order, you think it's the right order?
So in a way, yes, but they are the CTEs, the views and functions are used for different purposes. CTEs and views
True.
are most likely to be interchangeable. So if you have a CTE that you're using in one query, then when you write a new query, you think, oh, I wrote this already. Let me go and copy paste it from another query. Okay, that should be a clue that says this CTE should probably be a view that you can use. Functions are
Right.
different. Functions, I think you're right. There is a bit of a performance hit because a function can be called multiple times for each row. So the function has to be very, very fast, very performant, right? Because
Yeah.
if you're calling the function on a table that has a million rows, it's probably going to be called a million times over and over and over.
Okay, that's good. So now let's move to your second recommendation, which is the filter. Filter the
The
data
performance.
before you do, yeah,
Yep.
performance thing.
So I had an example actually recently where I saw in my current job, I noticed that there was a query that had run for 8 or 9 hours before it got canceled. And when I looked at the code, it was a pretty simple query, and it was using CTEs. However, it was using a CTE on top of a very very large table, a table that had billions of rows, and then it was doing the filtering outside the CTE. So select star from table inside the CTE, and then select star from CTE where say date in the last month. So what
Hmm.
the database was doing, it was actually trying to scan the entire table, basically read every single record on the table, and then filter it down to the ones that you actually want. That is very inefficient. That's very inefficient because sometimes, for certain databases, for example, Postgres, CTEs are considered as like temporary tables, like tables that you don't. There's no way to kind of like for the query parser to intelligently say, oh, you're trying to filter something within the table. Let me filter first and then select. It did the opposite. It selected all the rows, and then it was trying to do the filtering. So what I did is I took the same code. I just moved the where clause from outside the CTE inside the CTE, and the whole code ran in like 10 minutes. So
Yeah, that's a beautiful
right,
feeling, right? When you make small
you make a
change
small change
and
and,
big
and you
performance
get
gain.
a huge performance gain. So when I talk about performance, right, performance patterns, one of the
Mhm.
like the overall um, basic practice, the overall best practice is to try and filter your data inside of a CTE as early as possible, as much as possible before you do any other operations. So,
Any other
right. So if
operation.
you have a large table, but you only care about the last month's worth of data, put the where clause inside the CTE that says where created date in the last month. Then you can take that
True.
table and then you can join with it because that you're telling the database, the query optimizer, that I don't want to scan the entire table. I only want to scan the last X number of days. And so for say a database like BigQuery, if your table has daily partitions, so some tables are partitioned daily, which means that every day you get a new kind of like subtable, right? If and it keeps a record of all of the like the what data lives in each partition. So if you say you only want the last 30 days, it can discard like 99% of the partitions and never scan them and only scan those partitions that are in the last 30 days, thus making your query faster, making your query cheaper, and getting you the results in a meaningful time. Like you don't have
True.
to wait.
Right.
There are cases,
And I believe
yeah, sometimes analysts
true.
can write a query. They know that it's going to take a while, so they start the query, they execute the query, they go and have lunch, go and have a coffee, and then come back, and hopefully the results have ended. That is not that is not a good way to write your queries. Like if you're especially if you're writing a query from scratch, you want to be able to have a very fast feedback loop, right? So you can check your
Yes.
errors very quickly. So you want to work with a very small subset of the data.
Right. And I believe if you are in the world of relational databases, index plays a big
Yes,
role on what you are filtering, right? The columns, you have to pay attention to have clustered, non-clustered index, all those
correct.
things makes a huge
Yeah,
difference.
I've done my fair share of index tuning on SQL Server, and
Right.
yeah, index tuning is a lot more of like an art than it is a science. So picking the right
Mhm.
indexes for the columns and making sure that you are actually using those indexes. So, for example, things like okay, so one of the problems that I've seen in the past, even when you have an index on a table, let's say the index is on a date column, like a timestamp, which is a great index, by the way, because it can quickly search smaller and smaller partitions. Well, I've seen cases where an analyst will try and use a function in the where clause. So, for example, they will
Mhm.
say, convert this timestamp to date, and then search that the date is in the last 30 days. Now, when you use a function in the where clause, most query optimizers will not know how to make that query faster. So what they will end up doing is basically scan the whole table, apply the function, and then
Right.
apply the filtering. So
Right.
as much as possible, avoid using functions in the where clause. The same thing can be said for strings. So if you have, let's say, for example, you're searching for emails, and or you're comparing for like you're joining on an email address, and you want to, for example, extract the domain, and so you're only searching for people that have a Gmail account. So you would apply a function like a substring that says grab just the domain and check to see if it is Gmail. Well, that is also
Mhm.
a terrible way of like using functions in the where clause, which makes your queries much longer and far less performant. In order to make them faster, you have to use the like keyword, like keyword, like
Mhm.
percent Gmail percent. That will actually tell the query optimizer, okay, I want to search within this string, but it will then do it a lot faster. So that's a
True. True. So there are many techniques. I think you can write a almost a separate book on query optimizer and how
you
you
can,
can,
and
you
people have,
know, fine
yeah.
tune your
Mhm.
queries because there's so much to figure out. And all these different databases, they have their own nuances.
Exactly,
Specifically,
exactly. Yep, yep. What works in one
yeah,
database does not work in another. Um, the
true.
the positive thing is if you're using one of the cloud databases, they tend to kind of abstract the user away from having to deal with the indexes,
With a lot
with a
of
lot of
things.
things,
Yeah,
because they also store data in columns as opposed to rows, which makes it a lot easier to do
right,
aggregates on the data. And
right.
so, for example, when I was using BigQuery in one of my previous jobs, I completely forgot everything that I knew about index tuning because I no longer had to worry about it.
Mhm.
BigQuery would take care of
Yeah,
all of that. Same thing with Snowflake, although it's not. It's you still have to worry a little bit, but it's different. It's not the same. So yeah, each database has its
mhm.
own nuance.
Yeah, in NoSQL word, specifically in Cosmos DB and Mongo, I think same Dynamo,
Yeah,
the partition key plays a big role. If your partition key is properly
yeah,
designed and defined, everything will be smooth and you don't have to worry about anything. Otherwise, it can be expensive. Sometime you will get the records in good time also, but your bill will be huge because it has fanned out the query and looked at all the partition and
yeah,
all those things. So it's important for people to understand the nuances of each and every database.
yeah.
But I think your point is very valid as a pattern
Right, exactly. Some
that deal with less data as much
right.
as possible.
The idea behind a
True.
pattern is that it's like a best practice that you can take with you and apply it in multiple databases. And
Exactly.
then you can get into the
Exactly.
nitty gritty of
And
each
the
one.
Exactly. And the third one is about robustness of the data. That I think is pretty simple. That make sure by the time you come to query and start using the data, it's cleaned up and have all the anomalies, everything is taken
Yes.
care of in the pipeline of for your ETL or however the data is
Yeah.
coming in.
So in the robustness patterns. So again, this is something that I noticed working with multiple kinds of data. Um, it is so as a best practice, right? It's a good idea to always use a function like coalesce or is null.
Mhm.
So the ANSI SQL function is called coalesce. So coalesce value one, comma value two, comma value three, et cetera. It will pick the first non-null of those and use that as the result. So if you don't, if even if your column is not currently null, it's a good idea to use coalesce and provide kind of a default value for what that column should be. Let's say that column is like a date. Okay, the default value could be something like January 1st, 1900. So instead of having null,
Mm.
because like further downstream, certain BI tools like Looker or Tableau or Power BI or what have you, or Excel, they don't work very well with nulls. They don't know what to do with nulls. So what you can
Yeah.
do is you can replace those nulls with like a default value. So, but you would do that regardless. Like even if you don't think that there are nulls, you still do it because you never know that at some point in the future something could break in your data pipeline, and it's never caught, and you don't want your queries to break when the data
Right.
breaks. Another thing that another best practice that I tend to use a lot is when joining tables. I tend to always use a left join as opposed to an inner join, even if I
Mm.
know that the tables could be inner joined, even if I know that there's like a full, like all the values for the column in table A would exist in table B. I still use a left join because there were many cases where, well, some data is missing from table B. And so by using an inner join, you are restricting the number of rows. And by restricting the number of rows, your counts will be wrong, your sums and your averages will be wrong. Therefore, things like revenue or number of customers will be wrong. And so
Yeah.
I always like play it safe. I call it defensive coding, um, defense against dirty data, right? Let- let's give it a
Perfect. Yeah.
name.
Very good.
So I always go with a left join. So I take my say my main table, which could be like a fact table, could be purchases or transactions or whatever, and say I'm joining a dimensional table like products. Well, there may be a new product that has come up recently that we have sold, but it doesn't yet exist in the product dimension. And so if I do an inner join, it's going to be excluded from the results. And my sales numbers will be wrong, my revenue will be wrong, et cetera, et cetera. So I always go with a left join. Now, there may be systems that are like data warehouses that have been very carefully designed to ensure complete. I think the technical term is like with you have foreign key constraints and you have like I forget the exact term. So, but the idea is because in data
Mm.
warehouses foreign key constraints are not enforced, then you don't know if the ETL may very well be placing all the new products in the dimensional table, but it's not always the case. I've worked in
Mm.
companies where we had to manually update dimensional tables, and so very
Mm.
often there would be new data coming in from the transactional systems, and if you did an inner join, well, it would be excluded because it didn't exist
Yeah.
in the reports. And so I got into the habit of doing always a left join and then basically covering the nulls and saying if it's null, use kind of like an unknown or NA or et cetera, right? One of the things to keep in mind though, if you're using nulls, is if you replace integers with a default value such as like a zero or a -1 or -9999, well, that could be meaningful to the system because you might be summing up a revenue or you may be counting the number of users, etc. So
Count.
if you
Yeah.
use a zero could actually mean something as opposed to like if you know that okay, this column can never be zero, okay, you can replace it with a zero and then someone will know that if it's zero, okay, then the data is not known. But zero could be a valid value for that table. And so by replacing it with 0, you're basically making up information. You're feeding data
Yeah.
in, not necessarily on purpose, but you
Right.
could be kind of making data incorrect without
Incorrectly.
being aware of it. So default values are really important, and you got to be careful about which ones you choose.
True. Agreed. Because I think null also has another ramification. Different languages treat null differently. So if null is flowing in your data, the later it will reach to tool or your application or any
Yeah.
language, it can play differently. So that's a good, very, very
Yeah.
good point.
In SQL, actually, in SQL, just to clarify your point, because you make a valid point. Yes, and nulls in languages like a Python or like a C++ or C# or what have you, are you could actually compare null. You can say if value equals null, right? In Python or some other language. In SQL, you cannot do that. In SQL, nulls are very special. In SQL they mean it's unknown. So if you take a null value and you say equals null, that's not going to work. It's going to be false.
True. That's why you have an
That's why
is
you have an
null
is null
function.
function, right? Same thing if you take
Yes.
a null value and you add something to it. Okay, what happens to you if you add 100 to unknown? 100 plus unknown is still
Mm.
unknown, or 100 minus unknown is still unknown, right? So when you do these operations with nulls, you're always going to get null, regardless of what the
Yeah.
other field is. So it's important. Like nulls in SQL are very very different from, especially like
True.
if you were a
True.
programmer before and kind of used to nulls just being another value. It's different in SQL. You have to say is null or is not null. You cannot use the equals.
Yeah, true. So, August, I know we just talked about three
Yeah,
patterns here, but I believe your book has many more other patterns, and I will put a link to your book under the
thank
notes
you. Yeah,
section so people can go and buy it and read more detail. So this episode is mostly to give you the taste to audience, the taste what is there in the book, and hopefully they will go and read it
yeah, and
and learn more
I
about it.
actually have specific examples in the book. I use real world data to
Mhm.
explain all the patterns, and I have a project that you work your way through. As you go through each pattern, each chapter, you learn a new pattern, and you're also building an actual project. So at the end of the book, you're
Awesome.
building a table that is that's also like a type of pattern, a type of model, if you will, that is used in
Hmm.
analytics, right? So you create like a user table that has one row per user, and then each column is a metric for that user. For example, number of, in this case, I'm using the Stack Overflow database, which is very familiar
Hmm.
to programmers. So, and I create a table that has one row per user, and each column says, for example, number of posts total, number of comments, number of posts per day, number of thumbs up votes, thumbs down votes, etc. Et cetera. So I calculate
Hmm.
a series of metrics at the user level, which is then itself a pattern that can be used by analysts where they can replace a user with a customer, and you can basically calculate the same way you can calculate metrics at the customer level. Number of visits to the product page, number of times that they added items to the cart, to the shopping cart, how long did they spend on a particular page, etc., etc.